Alright, here's my circuit for the Scout robot. Over here you've got a distance sensor, servo to pan the camera left and right. This light sensor is a proxy for a video camera. Then we've got a hobby motor to drive the front wheels forward and reverse, a servo to turn an axle for the front wheels so that they can twist left and right. And then we've got an LED over here, which is my output transmitter. It could be replaced with a radio transmitter to make communication easier. Then this next receiver is a proxy for a GPS unit. The GPS unit would be larger. It's sized correctly in my CAD drawing, but it functions in a similar way. And then we have the actual IR receiver that's hooked up to the remote here, and a 9-volt battery to supply power for the hobby motor. Go back to the top of my code here. So if we go ahead and kick up the simulation here, it's going to kick on, and we're going to go ahead and highlight a few things here. We're going to get the lights on, make sure that's far enough away. Looks good. So first thing we're going to do is take a picture. So when you hit button 0, it is going to read the input coming in from the camera and then print that out and also blink the LED for this amount of time in milliseconds. There's a multiplier value for that that can make the light blink longer or shorter as well. Then if you need to tilt the camera left and right, you can do so with buttons 1 and button 3. There are 3 degrees of motion on each side, after which the servo will refuse to turn. Then you can go back to center all the way back through on the right side as well. The servo for the motor works the same way with 4 and 6, although it has more, it has larger chunks of motion, but fewer. So it has 2 bigger chunks instead of 3 small ones. Then the motor can drive in forward and reverse by using 2 and 8. We see here it's going forward, and then we got it in reverse there. While it's going in forward, it kicks on the distance sensor. So if this comes within less than 2 inches, it'll stop the servo motor. Then this will also print out how far away the object is. If you try and start the motor while the object is still too close, then it will refuse to start and print that line again. If you then go in reverse, for instance, and back that object further away, then you can once again go back into forward. When you hit position 5, that is going to stop the motor, and then it is also going to blink out GPS coordinates as well as print them. For the proxy, I have just saved these GPS coordinates as values, but if you had a real GPS sensor, it would take the position that you were currently at. Then that gets broadcast back to the other robots so they can use those coordinates to carry out various tasks in the garden. And here is all my code. It's organized and initialized by component here. So I'm just going to scroll through up here at the top. Then we've got the setup organized in the same order, going clockwise from bottom left, starting with that distance sensor. And then the commands laid out here. Button 7 and button 9 are still unprogrammed, and then the functions down here as well. Thanks.